In 1945, a computer filled an entire room, weighed 30 tons, and could barely calculate artillery trajectories. Today, your smartphone is millions of times more powerful, but we're not stopping there. Quantum computers now exist that can solve problems in seconds that would take traditional computers thousands of years. This is the complete evolution of computing, from mechanical beasts to quantum monsters. And what comes next will change everything. Computers didn't start with screens and keyboards. They started with gears, levers, and human operators. Over the past 80 years, computing has gone through 6 revolutionary stages, each one exponentially more powerful than the last. In this video, I'll show you every major type of computer ever created, from the mechanical calculators of World War II to the reality-bending quantum computers of 2026. Let's start at the beginning. Level 1, mechanical computers. These were the dinosaurs of computing. Before electronics, computers were purely mechanical. Machines like the differential analyzer and early IBM tabulators used physical gears, rods, and wheels to perform calculations. These weren't computers as we know them, they were more like super advanced calculators. The most famous example? The Harvard Mark I, completed in 1944. This monster was 51 feet long, 8 feet tall, and weighed 5 tons. It could perform 3 additions per second. Your calculator watch today is faster. But these mechanical computers played a crucial role. They calculated artillery tables during World War II, helping the Allies win the war. They proved that automated calculation was possible. The computer revolution was beginning. Level 2, vacuum tube computers, the first true electronic computers. In 1946, everything changed. Engineers at the University of Pennsylvania built ENIAC, the electronic numerical integrator and computer. Instead of mechanical gears, it used 17,468 vacuum tubes, glass cylinders that controlled electrical current. ENIAC was massive. It filled a 1,800 square foot room, weighed 30 tons, and consumed 150 kilowatts of power, enough to power 150 homes. But it was revolutionary. ENIAC could perform 5,000 calculations per second, over 1,000 times faster than any mechanical computer. These vacuum tube computers powered the early space race. IBM's mainframes ran NASA's Mercury and Apollo missions. Without them, humans would never have reached the moon. But vacuum tubes had problems. They generated massive heat, failed constantly, and consumed enormous power. The computer industry needed something better. Level 3, transistor computers. The breakthrough that changed everything. In 1947, Bell Labs invented the transistor, a tiny device that could do everything a vacuum tube could, but faster, smaller, and more reliably. By the late 1950s, computers started replacing vacuum tubes with transistors. The IBM 7090, released in 1959, was one of the first fully transistorized computers. It was 10 times faster than vacuum tube computers, but used only 1% of the power. NASA used IBM 7090s to calculate trajectories for the first orbital flights. Then in 1971, Intel created the microprocessor, putting thousands of transistors on a single chip. This was the birth of the modern computer chip. Computers could now fit on a desk instead of filling entire rooms. By the mid-1970s, hobbyists were building computers at home. The Altair 8800, released in 1975, was the first personal computer kit. It had no screen, no keyboard, just switches and lights. 2 college dropouts named Steve Jobs and Steve Wozniak saw the Altair and decided they could do better. Level 4, personal computers, computing for everyone. In 1977, the Apple II hit the market. It had a keyboard, color graphics, and could run actual software. For the first time, normal people could own a computer. Microsoft and Apple were born. Then in 1981, IBM released the IBM PC. It became the standard. By the 1990s, Windows 95 made computers user-friendly with icons, windows, and the start button. The internet explosion turned PCs into communication devices. Personal computers grew exponentially more powerful. In 1985, a top PC had a 6 MHz processor and 256 kilobytes of RAM. By 2000, PCs had gigahertz processors and gigabytes of storage. Today's laptops have processors with billions of transistors, running at 5+ gigahertz. But while personal computers democratized computing, scientists and governments needed something far more powerful for weather prediction, nuclear simulations, and code breaking. They needed supercomputers, level 5 supercomputers, the most powerful traditional computers ever built. Supercomputers are designed for one thing: raw computational power. The first supercomputer, the Cray 1, was built in 1976. It could perform 160 million calculations per second and cost $8 million. Today's supercomputers are incomprehensibly faster. The current fastest supercomputer in 2026, El Capitan at Lawrence Livermore National Laboratory, can perform over 2 exaflops. That's 2 quintillion calculations per second. To put that in perspective, if every person on Earth did 1 calculation per second, it would take us 250,000 years to match what El Capitan does in 1 second. Supercomputers predict weather, simulate nuclear explosions, fold proteins for drug discovery, train massive AI models like GPT-4 and beyond, and model climate change. They're essential for modern science. But even supercomputers have limits. Some problems are so complex that even the fastest supercomputer would take millions of years to solve. Problems like breaking modern encryption, simulating molecular interactions, or optimizing massive logistics networks. That's where the final level comes in. Level 6, quantum computers. Machines that break the rules of reality. Traditional computers, even supercomputers, use bits, ones, and zeros. A bit is either on or off. Quantum computers use qubits, quantum bits, that can be both 1 and 0 at the same time, thanks to a phenomenon called superposition. This sounds impossible, but it's real, and it means quantum computers don't just calculate faster, they calculate in fundamentally different ways. While a traditional computer checks possibilities one by one, a quantum computer checks millions of possibilities simultaneously. Google achieved quantum supremacy in 2019 when their Sycamore processor solved a problem in 200 seconds that would take the world's fastest supercomputer 10,000 years. IBM, Microsoft, Amazon, and startups like IonQ and Rigetti are all building quantum computers. In 2026, IBM's Condor processor has over 1,000 qubits. These machines are still experimental, extremely fragile, and require cooling to near absolute zero, colder than outer space. But quantum computers will revolutionize everything. They'll break current encryption, forcing us to redesign internet security. They'll discover new materials and drugs by simulating molecules perfectly. They'll optimize global supply chains, transportation networks, and financial markets in ways impossible today. And they'll accelerate AI development. Quantum machine learning could create artificial intelligence far beyond anything we can imagine today. So there you have it, the complete evolution of computers. From 30-ton mechanical calculators that could barely add, to quantum machines that exist in multiple realities at once. We've gone from 3 calculations per second to 2 quintillion per second in just 80 years, and we're not done. Neuromorphic computers that mimic human brains, optical computers using light instead of electricity, and DNA computers using biological molecules are all in development. The question isn't what computers can do today, it's what they'll be able to do tomorrow. And based on the last 80 years, the answer is anything. If you want to see more technology evolution videos, subscribe and let me know what tech you want me to cover next. Thanks for watching.